So in this video today we are going to discuss about two new concept that is very important for a stereochemistry for, let's say, alkane, and this is your Sawhorseprojection and Newmanprojection. Is very important for CSIR-NET, GATE, every exam. Okay, now also IIT-JAM, IIT-JEE. Okay, now in the previous video we have discussed on chiral center concept, wedge dash model, and Fisher projection, right? And the previous video link is there in the description box. You can look at that. Okay, now in that video, let's say we have discussed a molecule. We can follow that molecule as a standard molecule just for understanding that we have taken this. तो हमने ये molecule लिया था, bromine, hydrogen, CH3. So we have discussed that this is your OH conformation, right? Now if you can see this molecule, which conformation molecule, we can draw this molecule in a different way. Just like we're not going to use this dash like this beta bond or alpha bond or this bond concept. Instead of this bond, हम लोग क्या use करेंगे? Just a simple bond. That is, we can see that this CH3, this below, let's say we can numbering this carbon as a 1 and this a 2. So we can draw it like this, 1 and 2. Okay, now you have a CH3 and that CH3 is this. Okay, now you have a OH above the plane, we can write like this, OH. Okay, you have a hydrogen below the plane, so this is a hydrogen. No dash, no dash or no alpha or no beta bond. Okay, no. Okay, now for this two carbon center, you have a CH3 group, that is this. You have a bromine, that is the above the plane, so this is a bromine, right? And this hydrogen is below the plane, so this is a hydrogen. So this projection is called Sawhorseprojection, right? This is your Sawhorseprojection. Well, if I give you an example, let's say if I give an example on 2-butanol, can you draw it in a Sawhorseprojection? So 2-butanol, what is 2-butanol? First of all, you have to draw a simple structure. पहले हमको simple structure draw करना है. Like this is 1, so this is your 2-butanol, right? This will be 1 hydrogen, this should be CH3, right? So this is your 2-butanol, 1, 2, 3, 4. So this is a 2-butanol. So what we can do is that we can write this structure in a Sawhorseprojection. बहुत सिंपल है, ऐसे करके हम लोग ड्रॉ कर देंगे. ये 4 नंबर कार्बन इज दिस, ये 3 नंबर कार्बन इज दिस. इसके पास क्या है? 2 हाइड्रोजन है, एक above the plane, एक below the plane है. Now this is your this point. This 2 number carbon है this, so this is your 4, this is your 3, this is 2. Now हम लोग ऐसे करके लिख सकते हैं. इस कार्बन के साथ क्या है? हाइड्रोजन है, OH है. So we can write in an elaborate way for your better understanding. So this is a hydrogen and this is your CH3, right? We can write this way. So what is this? This is your wedge structure. Now this structure we can write in a Sawhorseprojection, and that is what you can write. This is a CH3, this is OH, this is a hydrogen, this is a hydrogen, this is a hydrogen, and this is your CH3, right? Okay. Now Sawhorseprojection is a little bit easy. Now what is a Newmanprojection? For a Newmanprojection, you need to understand a little bit more. Okay. Now okay, we can erase this part. Okay, So this is your Sawhorse position, right? Now we have to go to the Newman position. What you have to look at there is that you have to look at from here through this angle, okay? Through this angle, like in this bond. So to look at that. So what you're going to see, this is a methyl, this is a bromine. Okay, it's not. So what you can see, if you can see, तो हम लोग क्या देखेंगे, ओके तो हम लोग यहाँ से देख रहे हैं, तो दिस इज योर मिथाइल है, दिस इज अ ब्रोमीन, दिस इज अ हाइड्रोजन, ओके like this is a methyl, this is a bromine, this is a hydrogen, right? So we can draw it like this way. This is a methyl, this is your hydrogen, and this is your bromine. Now when you're looking at this bond, you cannot see this atom, right? When you're looking at this atom, you cannot see this atom, right? So there is a bond, you cannot see the back atom, so then you cannot see the back atom. Now what you can see in the back, what is there? So in the back you have this, in the back you have this, in the back what you have, CH3 is there, hydrogen is there, OH is there, right? So what is there in the back? Hydrogen is there, okay, and you have a CH3, and then you have a OH, right? So this is a Newman, so this is Sawhorse projection, and then you convert this to a new position which is called a Newman projection, right? It's very interesting projection. So हम लोग को कैसे डिटरमिन करना है, तो और एग्जांपल करते हैं. Let's say if I give you this molecule, okay, let's say this molecule, what is this, 1 2 3 4, so this is basically in butane, okay, this is your Sawhorse position, okay. Can you draw it in a Newman position? So the thing is that you have to look at this is just for understanding. If you look at this side, what you can see, CH3, this center is this center, so you have a 2 hydrogen. Now you have a circle. Now in the back side you can see this is a hydrogen, this is a hydrogen, and this is a hydrogen. So from this position you can see this methyl and this methyl are anti with each other, similar for that, this methyl and this methyl are anti with each other, right? So this is the Newman position. So okay, so you can see, now we can see that this methyl and there is a backside hydrogen, right? So this methyl and backside is hydrogen, so we can, what is the backside is there, like this, right? So there is an angle, this is called theta, we can denote as a theta, and this is called dihedral angle. So theta is your dihedral angle, okay. Okay. For this case, this theta value is 60 degree, right? Okay. For this case, theta is 60 degree between CH3 and hydrogen. Okay. Now we can see that for this molecule, if you can, हम लोग क्या कर सकते हैं, अगर ये सामने वाला जो पोर्शन है अगर हम इसको कांस्टेंट रखें और पीछे वाली हाइड्रोजन एंड CH3 को अगर रोटेट करें, देन व्हाट यू विल गेट, तो हम लोगों को क्या मिलेगा देखते हैं. So what is that? If I take this CH3, you have a hydrogen, you have a hydrogen, so there is a CH3. Okay, it's very important. Okay, now if you can rotate 60 degree in the back side, okay, back center we have to rotate, then what will happen? If you rotate 60 degree, then what will happen? So this angle is 60 degree, this angle is 60 degree, this angle is also 60 degree, this angle is also 60 degree, this is also 60 degree, this is also 60 degree, right? Now if you can rotate the back side, okay, what will you get if you rotate clockwise, clockwise, then this will go there, this will go there, this will go there. Okay, so what you'll get CH3 hydrogen. Now you have a hydrogen over here, you have a hydrogen over there, and you have a CH3 over here and you have a hydrogen over there, right? Okay, now again if you rotate 60 degree, what will get? तो हम लोग क्या कर रहे हैं, जो फास्ट वाला पोर्शन है ना, जो फास्ट वाला सेंटर ये कांस्टेंट है, बैक वाला जो सेंटर है हम लोग उसको रोटेट कर रहे हैं थ्रू क्लॉकवाइज 60 डिग्री ईच केसेस. सो हम लोग क्या मिलेगा, यहाँ पे CH3 आएगा, यहाँ पे हाइड्रोजन आएगा, ये हाइड्रोजन आएगा. इफ यू कैन रोटेट 60 डिग्री अगेन, what will get? CH3, this is a hydrogen, right? This is a hydrogen, this is a hydrogen, and this is a hydrogen, right? Okay, if you can rotate again 60 degree, what will you get? This here CH3, this is a hydrogen, this is a hydrogen. So you have a like CH3, you have a hydrogen, you have a hydrogen, right? Okay, so when I started rotating this molecule for each 60 degree, this methyl will go there, and this back side hydrogen will go there, and this hydrogen will go there. Again, if you rotate 60 degree, this will go there, this will go there, this will go there. Similarly for this, okay, this and the back side and this, okay. If you can rotate again 60 degree, what will get? This will come here, this will come here, and this will go there, right? So now we will have CH3, hydrogen, you have a methyl group, okay, you have a hydrogen group, you have a hydrogen group, right? Again if you rotate, okay, if you rotate now, if you again rotate 60 degree, then you will get the same this molecule. So if you can put a numbering A, B, C, D, E, F, again after rotation you will get A. Okay, now for structure of A, what you have, what is the dihedral angle? Let's say what is the dihedral angle for this molecule? So the answer is, the dihedral angle is 180 degree. Why? Because the most priority group is that CH3 and CH3. For this center, CH3 is the most priority group. So the dihedral should be, dihedral angle is between the most priority group, right? For these cases, this is the methyl and this is the methyl. So the dihedral angle between these two groups is 180 degree, right? Theta is 180 degree. What is the dihedral angle for this? Tell me. This is a 120 degree, right? Okay. Now what is the dihedral angle with this? This has become 60 degree. Okay. What is the dihedral angle between this? This theta is 0 degree. What is the dihedral angle? Theta is 60 degree. And what is the dihedral? Theta equal to 120 degree. And this case is 180 degree. So now, if you can see in that molecule, what do you have? These two methyl are in the trans, or we can say this is in an anti position or in an opposite position, right? Trans, or you can say this is anti. Now what you can see is that when you're talking about this, you have a methyl and hydrogen, and there is a certain interaction, right? Because they are both are in a same position, we can say, or we can say the structure as an eclipse structure. Okay, eclipse structure, right? And this one, we can say these two are near to each other, so you can say this structure is a Gauss structure. So where the angle is 60 degree. What is the Gauss structure? The angle, this theta, the Gauss condition is that theta should be more than 0 degree and below 120 degree. This is the condition for the Gauss. Okay. Now this is our same. Okay, same. So we can say that this is your eclipse structure. Again, eclipse. What about this? This is same Gauss, and this is again eclipse. So now if you can draw an energy profile diagram with a dihedral angle, so we can do it here in a little bit smaller way. So this is a dihedral angle, okay, and this is your energy. Okay, let's say this is a y-axis and this is a x-axis. You can draw. Now we can start from our lowest energy. So which one is the lowest energy? As you can see that these two methyl are anti or trans to each other, right? This is anti. So we can say that this anti conformation is more stable because there is no repulsion between these two methyl groups. Okay, so we can say this is your zero energy. So this angle is 180. You can say these are zero energy. Now if you go to that B conformation, where you have a interaction, dyadic interaction between this hydrogen methyl as well as hydrogen methyl. So there is a two hydrogen methyl and hydrogen methyl interaction. So there is a repulsion between the electron pair in the CH bond, the methyl CH bond, and the adjacent electron, right? Electron bond electron, adjacent bond electron. So this is having quite a few high energy, so you can say like this. Okay, no, that one you can say like this. Okay, now next is that this is the Gauss conformation where these two methyl are near to each other, but still they have a little bit interaction, so you can say this is the conformation, right? Now, so what is this angle? This angle should be, dihedral angle is 120 degree. Now what is this angle? Is dihedral angle is 60 degree, right? Now if you go to this D conformation, see this 2-methyl is having very high interaction, so you can say this is the high energetic molecule, highly unstable molecule, so this is having a high energy. Again, if you go to D to E, can you look at the E which is equivalent to C? So this is your A, these are B, and these are C, and these are D. Now after D, E is coming, so where these two methyl are Gauss, this is equivalent to C, so you'll get a C again, but actually the numbering is E, but this is equivalent to C. After C, you'll get F, where this C3 hydrogen interaction, C3 hydrogen interaction there, similar to B, so you'll get a same energy like this B. Okay, what is the dihedral angle between this and D? D is 0. Okay, now for this you can say this is 60 degree, so dihedral angle 60, and then you have a 120 degree, right? Now after that you will get A, so this is a 180 degree. So this is the high energy demanding, so there is some value we can value is not that much important, the understanding is more important. So here, which one is the most stable conformation in the Newman projection for N-butane system? So for N-butane system, which one is the most stable conformation. So this is the most stable conformation. As you can see, this one is the most stable. This one is the most stable. Okay, most stable. Which one is the least stable? So the least stable is this one. So this is this one. So A is the most stable, and we can write here, because there is no space, D is the least stable. Okay. Okay. All right. So if you can look at some other molecule, that will be better for your understanding. Do it. Okay. तो हम लोग और भी मॉलिक्यूल देख लेते हैं. We can see some other molecule. If I give you this molecule, let's say this, just dextamitide. These are salts, right? These are salts. So we can convert to a Newmanprojection. If you can put your eyes over here, what you can see, this methyl, if you can put a circle, then you have a methyl, right? There's a methyl and there's a hydrogen, right? So now this hydrogen is here, this hydrogen is here, and this methyl is here, right? Okay, now what you can do, we can rotate the back side. As you can discuss, we can rotate this back side under what you can do, we can do under 120 degree. Let's say we can do the under 120 degree. If you can rotate like this 120 degree, you will get this. So what are you doing? We're doing this is a clockwise rotation. So what will happen, this will go here and this hydrogen will go here, this hydrogen will go here, because the angle between this hydrogen and this methyl is how much? 120, right? So this is 120 degree. If you again rotate the molecule, what will get? तो अगर again हम लोग रोटेट करेंगे तो हम लोग को क्या मिलेगा? ये मिलेगा. तो देखो, this A, B, C, this A and C are same, right? So A is equal to C, because क्यों? क्योंकि यहाँ पे दो मिथाइल है, which is Gauss to each other. Okay. Also these two methyl are Gauss to each other. Now the CH3 hydrogen is there. So A and C are same, but in a B, if you can see, there is a how much interaction. So okay, for A and B is same, so we can consider only A, right? You have a CH3 interaction. So what you have? You have a CH3 interaction, and that should be Gauss, and you have a CH3 hydrogen interaction, Gauss. Now in a B, what you have? You have a 2 CH3. So that means you have quite a big interaction. So the thing is that this is highly unstable, but this is relatively stable. So we can say it is having less interaction with respect to this. So this is the most stable one. That's what I'm trying to say. But this is less stable, that we can say. But what is the least stable? That we have to figure it out in the eclipse conformation. What is the eclipse conformation? Let's say we can take this molecule, same molecule, you can write like this way, and if you can rotate, let's say if you can rotate this molecule in a 60 degree, then what will get? 60 degree. If you rotate the clockwise 60 degree, then what will get? This methyl will be there, right? And this hydrogen will come here, this hydrogen will go there. Okay, now see, you have a huge interaction between this. So this is the least stable one. Okay, so this is your least stable one. So in the next video we are going to discuss about the RS nomenclature.